from earlier, we saw that cotangent of theta is equal to sine of theta. Oops, not sine of theta. That's tangent, right? Is equal to cosine of theta divided by sine of theta. Cosine of theta divided by sine of theta. And so cotangent squared of theta would be equal to cosine square of theta divided by sine square of theta. All right, so I'm just going to go ahead and I'm going to substitute that in, right? So instead of cotangent square of theta, I'm going to have cosine square of theta divided by sine square of theta, right? And this is still being multiplied to sine of theta, right? All I'm doing is using relationships and identities to modify, right, the left side of this expression. And on the bottom, I have 1 minus sine of theta being multiplied to 1 plus sine of theta. So I'm going to go ahead and I'm going to distribute those binomials into one another, right? And I'm going to get a new expression. And so when I do that, I'm going to get this expression in the denominator. I'm going to have 1 minus sine square of theta. All right, cool. And then all this is supposed to be equal to 1 over sine of theta. All right, and so you may be thinking like, why are we doing this? It just looks like we're just plugging things in and not really going anywhere. But trust me, trust the process. We're getting there. Okay, and so now let's focus on the denominator. Right, in the denominator, I have 1 minus sine square of theta. Right, and I want you to think, where have we seen this expression before? You guys think, because we definitely have seen it before. Okay, and so this is we have actually seen this expression before when we were using the Pythagorean identity to find the value of sine or find the value of cosine, right? So Pythagorean identity says that sine squared of theta plus cosine squared of theta is equal to 1, right? But look what happens if I rearrange this equation to solve for cosine squared theta instead. So I'm going to get cosine square of theta is equal to 1 minus sine square of theta. And that's the exact same expression that I have in the denominator over here, right? So I'm going to substitute that in, right? So over here, cool. But before I do that, let me fix something in the numerator, right? Because clearly we can see that we can simplify the numerator a little bit more. We're gonna get cosine square of theta divided by sine of theta, right? Because this one of the signs here and this sign over here are going to cancel each other out. And then I'm going to be dividing by cosine squared theta, right? Because remember, I'm substituting 1 minus sine squared theta for cosine squared theta, right? And I was able to get this from the Pythagorean identity by rearranging the Pythagorean identity. All right, cool. So now it looks like we're getting somewhere, right? Because now I have this expression, right? So now I have that. What happened? Oh no, it's glitching a little bit. Oh, I think I could save it. Let's see. Okay, not too bad. All right, so this is the expression that we're left with. Cosine squared of theta divided by sine of theta, right? Divided by, oops, let me erase that. Okay, so cosine squared theta divided by sine of theta divided by cosine squared theta. All right, and then I'm gonna set this over 1, so I can divide a fraction with a fraction, and then I'm gonna get cosine square of theta over sine of theta multiplied by 1 over cosine squared theta. And now you guys can see it, huh? And then after I simplify this out, I'm gonna get that this is equal to 1 over sine of theta. So this is true, right? Is this expression, is the left side of this expression equal to the right side of this expression? And yes, it is. All right, cool.